Hi guys, welcome to my YouTube channel Physics Prince. My name is Deepak. I'm going to teach you all 9 subjects of physical science in detail. My courses are absolutely free of charges. My courses are going to help the students who are preparing for CSIR, NET, GATE, NT exam, PhD exam, SET exam, TIFR, Jest, IIT-Jam exam and other exams related to physical science. Okay guys, so this is the lecture number 14 of mathematical physics, and we are in which I'm going to discuss matrix, and this is the fifth part of the matrix which I'm going to discuss with you. Okay, and also I would request the people who haven't subscribed my channel yet, please subscribe my channel and watch my lectures, which are absolutely free of charges and going to help you to crack the exams related to physical science. Okay, so we were studying the eigenvalues and eigenvectors of the matrix. Okay, so I will start now. Okay, so we have studies the different properties of eigenvalues of different matrices. Okay, some properties are remaining which I'm going to discuss now. So let me just check, is am I audible or not? Okay, yes, I'm audible. Okay. Okay guys. So next property for eigenvalues is if Aij, this is the element of the matrix, okay, any element of the matrix Aij equal to Ij, okay, if Aij equal to Ij, so any matrix is in this form, right, Ij, in that case eigenvalues are, I will give example as well, okay, eigenvalues are trace of matrix into 0 0 comma 0 so on n minus 1 times, okay, n minus 1 times 0, n minus 1 times, okay, this will be the eigenvalue, right? For example is like a is a11, a12, a13, a21, a22 or and a23, a23, a31, a32 and a33. Okay, this is the matrix. So we have given this condition Aij equal to Ij, right? 1 1 1 2 3, right? Aij, a into Ij, 1 1 is Ij, right? 1 into 1 into 1 1, 1 into 2 2, 1 into 3 3, right? And this is 2 6 2 4 6, this is 4 2 4 6 and 3 6 9, okay, 3 6 9, because 3 1 is 3, 3 2 is 6, 3 3 is 9. Okay, this, if this is the matrix and this is 3 cross 3 matrix, okay, so eigenvalues are going to be eigenvalues are going to be eigenvalues are going to be this is trace a comma 0 comma 0, because 3 cross 3 matrix, so this is going to be trace means sum of diagonal element, right? This is sum of diagonal 1, 9, 4, 13 and 114, right? So 1 plus 4 plus 9 comma 0 comma 0, right? So eigenvalues are 14 comma 0 0, right? And here the degeneracy of 0 is n minus 1 times, okay? And this is asked in CSIR net question, okay? CSIR net question. This is asked, okay? Trace 0 0 0 so on, and 0 are n minus 1 times 0, okay? So that is called degeneracy. Degeneracy of 0 is n minus 1. So degeneracy for 0 for n minus n cross n matrix is n minus 1, okay? So this question is asked in CSIR net, okay? So eigenvalues of this is trace A 0 0, so 14 0 0. Well guys, I hope you understood it. Next point. Similarly for 4 cross 4 matrix, we'll find, okay? 4 cross 4 matrix, okay? 4 cross 4 matrix, 4 cross 4 matrix, and for this Aij equal to Ij, okay? So the 4 cross 4 matrix is going to be 1 2 3 4 and 2 4 6 8 and 3 6 9 12 and 4 8 12 16, okay? So this is 4 cross 4 matrix where Aij equal to Ji, okay? A11 A22 A33 Aij equal to Ij, okay? This is 4 cross 4 matrix, okay? And for this eigenvalues are simple, that is trace A comma 0 comma 0 comma 0. Degeneracy for 0 is 3 because it's 4 cross 4 matrix n minus 1, right? So we'll add this principal diagonal elements, this one, okay? So this is going to be 1 plus 4 plus 9 16, so 30 comma 0 comma 0 comma 0. These are the eigenvalues, okay? Similarly for 5 cross 5 matrix, 5 cross 5 matrix, if we take, then this is going to be this is trace A comma 0 comma 0 comma 0 4 times 0, right? Because this is 5 cross 5 matrix, so this is going to be 1 plus 4 plus 9 plus 16 plus 25, okay? Comma 0 0 0 0, right? And this is going to be 55 comma 0 comma 0 comma 0 comma 0, right? This is 55. So we can see here 1 square, 2 square, 3 square, 4 square, 5 square, right? In similar way. So for 5 cross 5, this is 55 comma 0 0 0 4 times, okay? Well, let me just check this sound is audible, okay? So this is going to, yeah, that's correct, sound is okay. Well, so next, similarly for n cross n matrix, if there is n cross n matrix, okay, and we need to find out and n cross n matrix is there, and Aij equal to Ij, okay? This is the condition, Aij equal to Ij. In that case, so this is going to be eigenvalues are going to be trace A comma 0 comma 0 comma 0 so on. This is n minus 1 times, okay? The degeneracy of 0 is n minus 1, and this is going to be trace trace A is going to be this is sigma n square, right, comma 0 comma 0 comma 0 n times. Okay, and this formula we know, right? Sigma n square is we know the formula, because here we can see that is 1 square, 2 square, 3 square, then 1 square, 2 square, 3 square, 4 square, then for 5 square, right? Similarly for n square, this is 1, and this formula we know, sigma n square, value of sigma n square equal to n into n plus 1 to n plus 1 upon 6 comma 0 comma 0 comma 0 n minus 1 times. Okay, this is the formula for sigma n square, right? N into n plus 1 to n plus 1 upon 6. This is important. Next is if any two rows or columns, if any two rows and columns are identical identical or scalar multiple of each other, then determinant of A equal to 0. Okay, if any two rows or columns are identical, okay, or the scalar multiple of each other, then determinant of A is going to be 0, and eigenvalue is going to be very important property. I will explain it with the example. Okay, eigenvalues are going to be trace A comma 0 comma 0 comma 0 so on n minus 1 times. Okay, for n cross n matrix. Okay, so I'll give example, like for example, is A is 1 1 1 1 1 1 1 1. Okay, this is the matrix, and we can see any two rows or columns are identical. It means determinant of A equal to determinant of A equal to 0, and eigenvalues is going to be trace of A, that is sum of principal elements, diagonal element. This is 1 plus 1 plus 1 comma 0 comma 0. Okay, so this is going to be 3 comma 0 comma 0. These are the eigenvalues, okay, for 3 cross 3 matrix. And similarly, next example is, or we have equation like this matrix A is 1 2 3 2 4 6 3 6 9. Okay, this is scalar, this is the matrix, or we can write this matrix like this. Okay, 1 2 3 2 into 1 2 into 2 2 into 3, right? And this is 3 into 1 3 into 2 3 into 3. Okay, right. So in that case, it is going to be, this is the A, right? So here this point, right? If any two rows or column are identical, the second point is, or scalar multiple of each other. So we can see scalar, this rows or columns are scalar multiple of each other, right? So in that case, same, determinant, the eigenvalue is going to be trace 0, 0, 0. Okay, and right. So similarly for this eigenvalue, that is lambda, is going to be trace a, 0, 0. Okay, so this is going to be 1 plus 4 plus 9, sum of diagonal elements, 0, 0, right? So this is going to be 14, 0, 0. Very important property. Okay, this one. If so, this is this one, right? This point. If any two rows or columns are scalar multiple of each other, right? So here we can say scalar multiple of each other, then in that case stress this eigenvalue is going to be this one, 4 zeros. We have got many questions on this property, guys. Okay, so very important one. These questions are asked in different examinations related to physical science. Okay, so this is the one. Now we'll do next question. This is we have been given a equal to 1, 0, 0 minus 1. Okay, this is given. This is the a given. Okay, and so this is a diagonal matrix, right? Because apart from diagonal elements, all elements are 0. So diagonal element, and then we know for diagonal matrix eigenvalues are PD, principal diagonal elements. Okay, so this is 1 minus 1. These are the eigenvalues. By property we know, right? Because it's a diagonal element, diagonal matrix. Okay, so this, right? And from characteristic equation also we can find out. We have find out directly by property, because this is a diagonal matrix, and for diagonal matrix eigenvalues are principal diagonal elements, right? This, and by characteristic equation we can also find out this is a plus lambda I is determinant of a plus lambda I equal to 0. So this is going to be 1, 0, 0 minus 1, this matrix, minus lambda 1, 0, 0, 1, determinant of this equal to 0, right? Meanwhile, I'm checking the connection as well. It's working fine at the moment. Okay, so this is going to be this one, and Q1, and now we'll solve it. So this is going to be 1 minus lambda 0, 0 minus 1 minus lambda, and determinant equal to 0, and this value is going to be 1 minus lambda square equal to 0. That implies lambda equal to plus minus 1, right? By characteristic equation we can also find out, right? But if we know the property, then we can easily find it. So that's why properties are very important. You should practice revise this thing and practices, so that if you will revise it and practice it, all the properties will be in your fingertips. Okay, next is this is also very important property asked using this property. Okay, so this is Cayley-Hamilton theorem. Okay, Cayley-Hamilton theorem. Cayley-Hamilton theorem. Okay, what it says? It says, very important, every square matrix satisfies its own characteristic equation. Okay, very important statement. Every square matrix satisfies its own characteristic equation. So every square matrix always satisfies its own characteristic equation. Okay, so this means characteristic equation is a plus lambda I, determinant of a plus lambda I equal to 0. Okay, so here we'll take the example. Okay, so let a equal to 1 2 2. Okay, so in that case we'll find a plus lambda I equal to 0. So this is going to be a, determinant of 1 2 0 2 minus lambda 1 0 0 1, determinant is going to be 0. Okay, so this is 1. So we'll solve it. This implies 1 minus lambda 2 0 2 minus lambda. Okay, this determinant is going to be equal to 0, and this is going to be 1 minus lambda into 2 minus lambda equal to 0, right? So we'll solve it. This is going to be lambda square minus 3 lambda plus 2I equal to 0. Okay, 2I equal to 0, right? And now we use Cayley-Hamilton theorem. By Cayley-Hamilton theorem, this is every square matrix satisfies its own characteristic equation. So this means a square minus 3a plus 2I equal to 0. Very important property. Okay, right? From this equation we can easily find out A inverse using Cayley-Hamilton theorem. Okay, so here how from this equation we can just how we are going to find it. Okay, we'll multiply by A inverse on left hand side. So it is going to be A inverse A square minus 3 A inverse A plus 2 iota 2 A inverse iota equal to 0. So this is going to be A inverse A into A minus 3 A inverse A plus 2A inverse equal to 0. A inverse equal to iota into A equal to A minus 3, because iota into iota, A inverse A equal to iota, right? And 3 into 3i plus 2A inverse equal to 0, right? And from here we can find 2A inverse equal to 3i minus A, right? And A inverse is going to be 3i minus A upon 2, right? So we can easily find out A inverse, right? So very important property. Okay, next we're going to solve next point. Next point, there is trick. Okay, so I'm going to write that trick for you. Trick. The first trick is if 2 cross 2 matrix, if 2 cross 2 2 cross 2 for 2 cross 2 matrix. Okay, 2 cross 2 matrix. Okay, 2 cross 2 matrix. So if we have to write any characteristic equation, we'll write lambda square minus trace A plus determinant of AI equal to 0. I is identity matrix. Okay, for this for the 2 cross 2 for 2 cross, if 2 cross 2 matrix is there, and we have to write the uh, characteristic equation, and if we know the eigenvalues, so we can write it using this formula directly. So you need to note down this formula and memorize it. Okay, so lambda square minus trace A plus mod A lambda I, right? So this one, so this if you know this, then you can easily write using Cayley-Hamilton theorem, A square minus trace A, sorry, this is really made mistake, trace of A, that's correct. Trace of, so easily we can write. Okay, so for this we can for this matrix, this matrix, we can easily write this matrix. Okay, because we know eigenvalues. So this is eigenvalues are 1 plus 2, right? Okay, yeah. So trace of A, trace is sum of diagonal element for this matrix. This is this one 1 2 3, right? Trace. This is going to be trace of A is 3. This is here, this is lambda. Okay, lambda. So this is going to trace A, that is A is 3, right, for this matrix. 3 lambda 3A plus determinant of this matrix is this one, determinant 2, right? So this is 1 2 0 1. I'm writing here matrix is 1 2 0 1 for this matrix we are talking about. Okay, so this is 1 2 0 2, sorry, 1 2 1 2 0 2 for this matrix we are talking about. Okay, so this is going with 3A and determinant is 2I equal to 0. So we can write like this. Okay, by trick. Second trick for 3 cross 3 matrix. 3 cross 3 matrix. For 3 cross 3 matrix, so it is going to be characteristic equation we can directly write lambda cube minus trace of A lambda square plus minor A11 plus A12 plus A11 A22 A33 lambda minus determinant of AI, okay, equal to 0. So this is also for 3 cross 3 matrix. We can directly write the matrix, directly write the characteristic equation. That is very important, that lambda 3 minus trace A lambda square plus minor A11 A22 A33. So it's easily we can find out A11 A22 A33 minor of that minus lambda AI equal to minus determinant of AI equal to 0. Okay, so this is the so here you can use Cayley-Hamilton theorem, and then you can put the value of A as well. Okay, so this is the trick, guys, for writing directly the characteristic equation. Okay, and then you can use Cayley-Hamilton theorem. Well, this is the one. Next question we are going to do. next is there's a question. Okay, there's a question that is A is given 1 2 3 0 2 3 0 0 2. Okay, this is the one. Okay, and so the first we'll find out. For this we need to find out, yeah, I'm giving example for how to use the characteristics. I have a given, so we have given this matrix, right? And so it's 3 cross 3 matrix. So I'm going to write. So just guys, give me 1 minute. Okay, I have just got a work. 1 minute. Okay guys, so I'm starting now. So this is the equation, and we have to write a characteristic equation for it. Okay, we have to write characteristic equation. So because we can see that it's a upper triangular matrix. Okay, this is, like, you can see that this is the because the elements, all elements below this diagonal line is 0, right? So upper triangular matrix, upper triangular matrix, upper triangular matrix. So it means eigenvalues are going to be principal diagonal elements. Okay, so for upper triangular matrix and the lower triangular matrix, right, the eigenvalues are going to be diagonal elements, right? So this is 1 2 and 2. These are the eigenvalues. Okay, so directly we found eigenvalues. Now we'll write the characteristic equation. So this is going to be by this trick. This is the formula you need to note down and memorize. So this is lambda cube minus stress of A plus minor. How to find minor, that I'm going to also tell you. 1A11 plus A12 plus A22 plus A33. Okay, plus determinant of A I. Okay, so this is minus, guys. Okay, this is minus. This should be like in that first plus, then minus, then plus, then minus. Okay, plus minus, right, like that. Okay, so we'll find it. So how to find like this A11 minor means A11, right? A11 means this one, right? This line get cancelled, this line get cancelled. 2 to the 4, 4 minus 0, that is 3, 4, right? Similarly A22, how we are going to find this A2? This line get cancelled, this line get cancelled. 2 0 0 0, this one 2 2, this line and this line got cancelled, right? Okay, this is going to be 0. Okay, right? So similar, so now we'll in this way we'll find this. Okay, so this is going to be lambda cube minus trace of A is 1 plus 2 2 2 2 4 5, yeah, 5A. Here is lambda. Okay, this is lambda square and this is lambda. Okay, so 5 lambda square, 5 lambda square plus the minor a minor of a11, a22, a33 is going to be 2 plus 2, 2 plus 2 plus 2, and then minus 4i, right? 4, because determinant of this is going to be 4. These are like from there, this one, right? 2. So this is 2 actually. Yeah, this is 4. This one and this one. Okay, so this value is going to be lambda cube minus 5 lambda square plus 8 lambda minus is going to be 0. Okay, so like this we can write this. Okay, so just I want to tell you this formula you need to note down, and then you can easily find out the characteristic equation for 3 cross 3 matrix. Okay, next point. Next point is, there's a trick for this also, very important trick. Okay, I will solve one question using this trick. So this trick is n cross n square matrix. Okay, so if there is a n cross n square matrix, and if rank of a is less than equal to n, for n cross n matrix, that implies non-trivial solutions of equation. Okay, non-trivial solutions of matrix, or many solutions if rank of a is less than n. Okay, for n cross n matrix. Similarly, if rank of matrix is equal to n, this implies unique solution. Okay, unique solution means trivial solution. Okay, so the matrix have unique solution if rank of matrix is n, for n cross n matrix. Okay, very important trick. And now I'm going to solve question for this. Okay, there's a question using this trick. Okay, there's a question which is asked in CSIR net 2017, and it's a December question. Okay, December question. Well, so now I'll write as a question is, matrix is given, that is 1 1 1 1 2 3 and 2b 2c. Okay, this is matrix, and an x y z equal to 0 0 0. So this is the matrix given. Okay, matrix equation is given. Okay, which is clearly it's a homogeneous equation, matrix equation, right? Now you need to find out condition for non-trivial solution. Condition for non-trivial solution. You need to find out what is the condition for non-trivial solution and corresponding solution. Corresponding solutions. Okay, you need to find and options are given. Option number A, B equal to 2C and XYZ. XYZ is going to be 1 upon root 6, 1 minus 2 and 1, sorry, minus 1. Option B is C equal to 2B and XYZ equal to 1 upon root 6, 1 upon root 6, 1, 1 minus 2, 1, 1, 1 comma 1 minus 2, okay. And option C is B equal to C plus 1, okay. B equal to C plus 1 and XYZ equal to value 1 upon root 6, 1 comma minus 2 comma 11, and option D is C equal to B plus 1 and XYZ equal to value of XYZ equal to 1 upon root 6, 1 upon root 6, 1 upon root 6, 2 comma minus 1 comma 1, okay. So this is for matrix equation, okay, where there is a n cross n matrix, right? So for and if rank is n, rank of matrix is less than n, then that matrix equation has non-trivial solution, means many solution. If rank is equal to n, then the matrix has trivial solution, means unique solutions, okay. So this is the question asked in 2017 and I'm going to solve it for you, okay. Very good question actually. So the equation is given in this form, okay. So I can write this equation in this form like this. 1, 1, 1, 0, 1, 2, 0, B minus 2, 2 into C minus, okay. 1, 1 or 1, 2, 3, 2B, 2C, right? 0, 0, 0. Like this we can write, okay. So now for this the matrix is, we'll write the matrix, that is 1, 1, 1, 1, 2, 3 and 2B, 2C, right? So this is the one, and we know if rank is because we'll make this we'll convert this equation into upper triangular matrix, right? So that we can use rank property, okay. So it's very easy. So we'll use properties, okay. The property which you are going to use is that R3, the row R3, this R1, this is R1, R2, R2, right? R3 tends to R3 minus 2R1, and second we will use second property we are going to use R2 equal to R2 minus R1, okay. These two operation will do in the matrix, and we know that how to do it, okay. So it is going to be operation after this is 0, 1, 1, 0, 1, 2 and 0, B minus 2 and 2 into C minus 2. Okay, this matrix will get after this operation. Okay, and then again, now we can see this one, right? And now again we'll do one operation, that is R3 tends to R3 minus B minus 2 R2. Okay, B minus 2 R2. Okay, so in if we do this operation, very simple, we have already done this operation in determinant in 11 and 12, right? Okay, so this in determinant chapter. Okay, so this is going to be 1 1 1, and this is going to be 0 1 2, and this is going to be 0 0 2 into